the original classic structure of atom, the scientists thought that electrons with negative charge are orbiting around the nucleus, the same way planets are orbiting around sun. But then physicists calculated, they said there is something wrong with this because negative and positive attract each other. And mathematical formula showed that this attraction should result to the electrons of getting closer and closer and closer and eventually fall into the nucleus. Then they said this picture is not right. If this was true, electron would have dropped into the nucleus, matter would self-destruct, and we know matter does not self-destruct. Then they say the idea of looking at electrons as a particle can't be right. So they try to come up with a theory which can explain that matter is not self-destructing, electrons are not really particle. And they say electrons behave like a wave behavior.
So what's the difference between an atom moving inside the neutron and like around it than it being just like staying there? Does it make...
Are you talking about neutrons or electrons?
So yeah, the electrons, yes, when they're moving around the nucleus. So is it different if they're not moving?
They drop into the nucleus. It's just two magnets with opposite ends.
Okay, so the equation would be different then.
Right. The equation said that this behaving like a wave, you know how a wave goes up and down, goes up and down, and goes up and down. They say electrons are waves around nucleus. They are scattered, negative charge, they make a cloud, and this cloud has a shape. Have to look, if you look at the sky today, is a little cloudy, I see. Look at the clouds. Do you see some of them have certain figure? They have a shape. The same thing, they said electrons have a shape. Your clouds around nucleus, they have a shape. And they're scattered there. And what is most ridiculous is the fact that electrons can be in several places at the same time. How is it possible? We can't understand. Can you be at the college and in downtown at the same time? No, but electrons can do that. Can be more than two places. Actually, they come into the existence and they disappear and they come back to the existence and they disappear. That's what this theory is saying, quantum mechanics. This theory is not imaginable by us. However, it's a theory which is behind all the computers, all the cell phones, and all the digital system we are using. It's working. It's a good theory. It's working. It's not understandable. So, they are a scattered cloud, but they have restrictions. They know where they are supposed to be. They can't be anywhere that they want. This is shape of one electron. One electron has got this spherical shape. The nucleus is in the center of this sphere. This electron is everywhere around the nucleus. It's a cloud. It's a negatively charged cloud. Because this electron cloud has a spherical shape, and I didn't do a good job in my sphere, we call it S orbital. So that's one electron. And that's the nucleus in the center. Amazing. Guys.
So all the different electrons have all the different neutrons in them?
Well, no, neutrons is not with electrons. Neutrons are in the
nucleus. Sorry, I meant the nucleus.
That's okay. Yes, yes. They love nucleus because nucleus has positive charge. They have negative charge. They love each other. They're attracted together. So guys,
okay.
Thank you, Patron. In fact, there is another electron which has larger electron crowd. It's further away from the nucleus. This sphere has larger radius, larger diameter. We call it 2s. So in other words, look at this. This is 1s. And look at this. This is 2s. This is 3s. This is 4s. And this is 5s. Another word, do you see 5s is further away from 1s? So which one are more attracted to nucleus, 1s or 2s?
1s.
1s.
Beautiful. So can I say 1s has less energy than 2s, which has less energy than 3s, which has less energy than 4s, which has less energy than 5s. Why? If 2s can go, yes, if 2s can go this far from the nucleus, 1s can go this tiny far. It doesn't, tiniest space, it doesn't have enough energy. In other words, suppose Shasta College was open every day around noon. I go run around chemistry building and you run around the campus. Can I say you have more energy than me because you are going a larger circle with larger diameter or larger radius? Yes? So this is telling us that energy of electrons are different. Different energy. The energy order between all these s orbital changes as they go to higher layer of energy. Can I summarize this and say this? Suppose this is nucleus. So this is first shell, second shell, third shell, fourth shell, fifth shell. This is 1s. This is in second shell 2s, 3s, 4s. Can I do that? 5s. Which has more energy? Of course, 5s has more energy than 1s. You may say, who cares, guys? You know how you take medication. Some people have depression, they take medication, they feel better. It's electrons, behavior of electrons. The difference between happiness and lack of it. When you fall in love, it's electrons in action. When you hate somebody, electrons in action. When you get angry, electrons in action. When sodium, a metal, catches fire, electron in action. When chlorine is toxic, kills bacteria, can kill people, it's electron in action. When chlorine and sodium react together, you make salt, it doesn't kill, it doesn't catch fire, electrons in action. So property, chemistry is defined by behavior of electrons. Their behavior depends on their energy.